In 1950, a physicist named Enrico Fermi sat down to lunch with colleagues at Los Alamos. They were talking about UFOs, alien life, and whether faster-than-light travel was possible. And somewhere between the soup and the sandwich, Fermi looked up and asked one question: where is everybody? It has been 75 years since that lunch. We have pointed telescopes at the sky. We have listened to billions of frequencies. We have found nothing we can confirm. And the more we learn about the universe, the stranger the silence becomes. In 1961, astronomer Frank Drake wrote an equation on a chalkboard in Green Bank, West Virginia. He was preparing for the world's first scientific meeting on the search for extraterrestrial intelligence. Carl Sagan was in the room. The Drake equation was meant to organize the question. It multiplies 7 factors: the number of planets that could support life, the fraction where intelligence develops, and the average length of time a civilization broadcasts before going silent. That last variable, how long civilizations last, is the one we cannot know. Plug in optimistic numbers, and the equation gives you 50 million civilizations. Plug in pessimistic numbers, and you get 20. Either way, even 20. The Milky Way should not be quiet. The Milky Way has 200 billion stars. Many of those stars are billions of years older than our Sun. A civilization that formed around one of those older stars could have had a billion-year head start on us. A billion years is enough time to colonize every star in the galaxy. And yet, nothing. That gap between what the math predicts and what we observe is called the Fermi paradox. And there are 3 serious explanations for it. We have not been passive. In 1960, Frank Drake pointed a radio telescope at a nearby star for 2 months. He heard nothing useful. We have been listening in some form ever since. Billions of radio frequencies, thousands of target stars, the most advanced signal detection equipment in human history, and 65 years of near-total silence. There was one exception. In 1977, a radio telescope in Ohio detected an anomaly, a strong, brief burst from deep space at the exact frequency hydrogen transmits on. The frequency scientists predicted aliens might use. The astronomer reviewing the printout circled it in red pen and wrote, "Wow." It has never been heard again. Now here is what makes the silence truly strange. We are not just listening for radio signals. A civilization millions of years more advanced than us should be visible in other ways. In megastructures, in harvested starlight, in engineering on a scale we could not miss. We have looked and we see none of it. The universe, everywhere we look, behaves as if it is dead. So, why? The first explanation is the simplest. We're alone because no one else made it, not because something killed them, but because the conditions for complex life are so rare that Earth is essentially a cosmic accident. This is called the rare Earth hypothesis. Consider what Earth has that most planets don't: a large moon. Earth's moon stabilizes our axial tilt. Without it, our seasons would swing chaotically over millions of years, and complex life might never have taken hold. A Jupiter, a giant gravitational shield in our outer solar system. Its gravity deflects comets and asteroids that would otherwise strike Earth roughly 1,000 times more often. Plate tectonics. Earth's moving crust cycles carbon through the atmosphere. This stabilizes our temperature over millions of years. Among the exoplanets we've examined, plate tectonics appears to be unusual. Our position in the galaxy, too close to the galactic center, and radiation from dense stellar activity sterilizes planets. Too far out, and there aren't enough heavy elements to build complex chemistry. Stack all of these requirements. The right kind of star, the right location in the galaxy, a large stabilizing moon, a giant outer system shield, active plate tectonics, and the probability of any given planet having all of them gets very small. The rare Earth hypothesis says, the silence makes sense. We aren't missing anyone. We are the accident. It's not a comfortable thought, but the second explanation is less comfortable still. Chinese science fiction author Liu Cixin described the second explanation like this. Imagine a dark forest at night. Every hunter in that forest knows other hunters exist, but no one knows whether the others are friendly or hostile. And in a forest where some hunters will kill you the moment they find you, the rational strategy is silence. Applied to the universe, civilizations that survive long enough learn to stay hidden. The ones that broadcast, that try to be found, get found by something older, something that does not negotiate. And then they go quiet. The civilizations that remain are the ones you will never hear from. This is called the dark forest theory. It's speculative. It assumes universal aggression, which may not be true. But here is what makes it hard to dismiss entirely. We have already been making noise. Radio and television broadcasts have been leaking into space for over 100 years. Our radio bubble, the sphere of signals that has reached space, extends about 110 light years. The Milky Way is 100,000 light years across. We have introduced ourselves to a fraction of 1% of our own galaxy. And in 1974, we aimed a deliberate message at a star cluster 25,000 light years away. Some scientists thought this was reckless. Stephen Hawking warned that contacting an advanced alien civilization might go the way first contact usually goes, badly for the less advanced party. Whether the dark forest is real or not, it leaves a question we have never seriously answered. Should we be broadcasting at all? The third explanation is the one that changes how you look at the news. In 1998, an economist named Robin Hanson published an essay. It was called The Great Filter. Are we almost past it? His argument begins simply. Getting from dead matter to a civilization that can reach the stars requires many steps. The right star and planet. Life emerging from chemistry. Simple cells becoming complex cells. A transition that took nearly 2 billion years on Earth. Multicellular life, and then animals with intelligence. Technological civilization, and finally, reaching other star systems. Hanson's insight was this. We observe no civilizations at the final step. Therefore, at least one of those steps must be nearly impossible. A filter, something that virtually every path through that sequence fails to pass. The question that keeps Hanson's readers awake, where is the filter? Scenario 1. The filter is behind us. Maybe the nearly impossible step was the emergence of life itself. On Earth, life appeared within the first billion years. Fast, cosmically speaking. But maybe that was luck. Maybe on most planets, chemistry never crosses the line into biology. Or maybe the hard step was the transition from simple cells to complex ones. That transition took nearly 2 billion years on Earth and happened exactly once. If the filter is behind us, we are the extraordinarily rare survivors. The universe is empty because we are one of the only things that made it through. We are alone, but we are safe. Scenario 2. The filter is ahead of us. Maybe life is not rare. Maybe intelligence is not rare. What's rare is surviving what intelligence eventually builds. Nuclear weapons, engineered pathogens, runaway climate change, artificial intelligence without adequate control. The pattern, if it is a pattern, is that every civilization, once it reaches a certain level of technological power, destroys itself, not out of malice, but because the ability to destroy a world arrives faster than the wisdom to prevent it. If this is the filter, the silence is explained. Everyone reaches this point. Almost no one gets through. And we are at this point right now. Now here is the darkest detail of the Great Filter. It concerns Mars. If we were to discover life on Mars, even a fossil, even a single microbe, most people would call it the greatest scientific discovery in history. Robin Hanson and philosopher Nick Bostrom argue it would actually be terrible news. Because if life evolved independently on Mars, it means life is not rare. And if life is not rare, the filter is not in the early steps. It is in the later ones. It is ahead of us. As Bostrom put it, no news from Mars is good news. The barren red planet is the best outcome we could hope for. And we have not passed the filter yet. Here is what we actually know. We have been a technological civilization for about 200 years. Our signals have reached about 110 light-years into space. The Milky Way is 100,000 light-years across. We have barely whispered. We are also extraordinarily bad at listening. In 65 years of searching, we have sampled a vanishingly small fraction of the sky. We don't know if there is a great filter. We don't know if it's behind us. We don't know if we're alone. What we do know is smaller and more important. We are the only civilization we are certain of. That makes us responsible for something we have barely begun to take seriously. If we are the only ones, we are the universe's only chance at being understood. The only thing in 100 billion light-years capable of asking why. If we are not alone, we should learn considerably more about our neighbors before we say hello. The Fermi paradox is not just a puzzle for astrophysicists. It is a question about what kind of civilization we choose to become. The universe is 13.8 billion years old. Civilizations have had time to rise and fall many times over, and the sky is quiet. Either we are a miracle, or we are a warning, or we are simply early. No one knows which. But the question a physicist asked over lunch in 1950 remains the most important one we've never answered. Where is everybody?